Hello viewers, welcome back to my channel. In today's video, we will learn how to derive the key analysis variables of the ADaM BDS dataset structure that are the base, ABLFL, change, and the percentage change variables. We will walk through the SAS code step by step, starting with the dummy dataset and end with the final derived dataset. So let's get started. So right now, I am using a dummy dataset for this video, which I have created for ADVS. And in that very dataset, I am keeping the use subject ID, param CD, the treatment start date, the ADT variable, and the AWARE variable, because these are the only variables which I will need for the derivation of the baseline flag and the base change and percentage change variables. Although I'm using a dummy data set right now, but when you are working on any study, what you can use is you can use your study ADSL and ADBS dataset and merge the two datasets based on your use subject ID coming from your ADSL. Why we need ADSL? Because the TRTSDT variable, that is the variable which we have in your ADSL dataset. So once you have done the merge on the ADSL and ADBS, you will have the TRT-SDT variable also in your resulting intermediate dataset. Since I am not creating a dummy ADSL here, so what I have done is I have instead used the TRT-SDT as a part of the ADBS underscore raw dummy dataset, which I have created here. So in this dataset, what I am doing is I am having three subjects data for the systolic blood pressure param CD of ADVS, and I have the treatment start date for all these three subjects and their respective ADT. ADT is nothing but the VSDTC which we have in your vital signs data, and the AVAL is the result of the param CD here. So if you run this, you will have the dummy dataset created with the required variables which will be used in this video. So you can see that for the three subjects, we have the param CD created, the TRT's SDT date is also there, and the ADT variable and the AVAL variable. Now the next step is, since we want to derive the baseline flag, and as we know that the definition of the baseline flag is that we have to flag the record which is the baseline record. Now comes the information that how to identify the baseline record. So in this case, the baseline record is the record which is having the last valid result, last record before the subject has taken the study treatment, the first dose of study treatment, and the result value is a valid result value. And this has to be derived for each param series. So that's why what we are doing is that we are sorting the dummy ADVS dataset which we have just created by the use subject ID, param CD, and ADT. What is happening here is that when you sort using the param CD, first variable being the use subject ID, then for each subject, we will have sorted the dataset for each param CD1 first, and then within the param CDs, we have used the ADT variable. So that means the first widget or the first record which is having the lowest date, that is the VSDTC, that is the lowest date record will come at the first record, and then as we progress with the during the study and in the study, the assessments are done and we will have the records in that chronological order. So to make sure that the records are present in the correct ascending date order, we have used the ADT variable as the sorting variable here. So once we have sorted this data set using the use subject ID, param CD, and ADT, we will have the resultant data set such looking like this. You can see that the dates are in sorting order now. Moving ahead with the derivation of the baseline flag. So now from this resultant data set, what we want to do is we have to filter out the record, which is the last record before the subject has started taking the study treatment drug. So the TRT-SDT variable is the variable which will have the information of the date when the subject has started taking the study treatment drug. That is the date of first dose the subject has taken. So from the TRT variable, to TRTSDT variable, we note that date the subject has started the dosing, and we will compare this date with the vital signs assessment date, which is the ADT. And if the assessment of vital signs is done before the subject has taken the study dose, then, and another point that we have, the A-val should be a valid value. So valid value means that it should have a valid response. Sometimes the data is dirty and we might have some invalid responses like not any, NA, or even null value. So those records cannot be considered for the baseline derivation record. So right now, since we, from seeing the data, we know that we do not have any invalid responses, the only filter I'm using is that the A-val is not equals to missing. But in case if you do have in your data dirty data like values coming as NA, NE, or something which is not the correct data, then you can use those values as well. That do the A-val should not be null as well as those values. So that type of filter you can use. So right now I'm using the filter that A-val value is not null and your ADT is less than the treatment start date. So if I'm going to only read those records from my ADVS underscore raw data set in my ADVS underscore base. And since I'm using the first dot last dot concept, I am using the by statement to make sure that when the data is being read from the set statement, it is also simultaneously sorted by the uSubject ID and param CD. So in this way, once what will happen is the dataset which we are reading from ADVS is the records where this condition is met. So if we see the ADVS, although we know that AVAL is not missing for any record, let's see the TRT and ADT comparison. So if we talk about the first subject, for the first subject, the TRT SDT is the 10th of January 2023. And we know that the 15 Jan is after 10 January. So for first subject, the first true record will be read. And similarly, for the second subject, we will have the first two record again. And for third subject as well, the first two records. So in this case, out of the 9 records from the ADVS underscore raw data, for each subject, we will have 2 records being read and we will have only 6 records being read. So if let's do one thing. Let's see till this point how many records we are reading, because we are using the last dot uSubject ID after this, then it will reduce further records. So before any applying this last dot first dot concept, let's see how many records are being read because of this where condition. So let's run this. And you can see we have only the 6 records which we have discussed. Here, the first record is having the 2 records, second also 2 records, and the third also 2 records where your ADT is less than the TRT SDT value here. So now from this, to identify the baseline record, we have to make sure that we are reading only the record which is the last observation before the subject has taken the study drug. So for first subject, in this scenario, the last observation should be the second record. And similarly, for second and third subject, it is the second record here. So to achieve this, to read only the last observation in this last observation from for all the subjects in this scenario, what we will do is we will be using the if last dot uSubject ID concept. And if we apply till here, let's apply till here, we will have only these 3 records being read. So these are the records which are the baseline records for us. And since we have identified these, we will mark the ABLFL flag as Y for this. So the next step, what we are doing here is just marking those records with ABLFL equals to Y. So the resultant data set in this case will have the 3 records, for one for each subject here, and the baseline flag will be populated as Y. So what we have done in ADVS underscore base dataset is that we have filtered out all the baseline records and we have created the ABLFL flag and populated it as Y. So now the next step is to merge this data set back to our original data set, that is the VS underscore raw data set, to make sure that we are having all the records in our resultant data sets which are present in our VS data set. And along with that, we are also having the baseline flag variable populated for the from the this data set which we have created just now. So for to achieve this, we will merge these two data set where we are keeping only the required variables from the ADBS underscore base data set. So to merge these two data sets, first we have to sort the two data sets based on the uSubject ID, param CD, and ADT variable. Both are sorted by the same variables, and the same by variables are being used as the by statement for our merge here. And since the ADVS underscore raw is the dataset which is having all the 9 records, and we are giving the alias here as in equals to A, and we want to keep all the records from this dataset, we have used the if A condition here. So what will happen here is that we are in ADVS data set which we are creating here, we will read all the records from ADVS underscore raw, that is our original ADVS data set in this case. But apart from that, what we are doing is we are merging the ADVS underscore base file data set to make sure the baseline flag which we have derived in the last step is also created in our resultant data set. So if we run this, you will see that in the ADVS underscore base dataset, we have the 3 records, and the resultant ADVS which we have just created, we are having all those 9 records, but we are also having the baseline flag being created here, and the baseline flag is populated only for the records which was identified as the baseline record. So in this way, what we have achieved so far is we have achieved the derivation of the baseline ABLFL baseline flag in our ADaM dataset. Now the next step is to populate the base value from the resultant dataset. So base value is nothing but the AVAL value of the record which is identified as the baseline record. So what does that mean is that for this subject, that is subject 101, the ABLFL was flagged for the second subject where the AVAL is 135. This makes that for CIS-BP, that is the systolic blood pressure param CD, uSubject ID 101 has the base value of 135. And similarly, for second subject 102, the base value for systolic blood pressure is 145, and for 103, it is 138. So now we want to create another variable here, which will be the base variable, and we want to populate the base values for all the records for these subjects respectively with their base values. Please note that the base value is not populated, normally is not populated for the pre-baseline records. So following that logic, in this current video, we will be keeping the base value missing for the pre-baseline records. When we say pre-baseline, that is the record which is prior to the record identified as baseline record. So to achieve that, what we are doing is, again, we are using the last generated ADVS dataset, and we are again keeping we are setting the ADVS by using the uSubject ID and param CD as the sorting variable here. And the next step is we are creating a base eval variable which will be capturing our base value first. So how we will be using this base eval? We are as I have told, that for the pre-baseline records where we are not going to populate the baseline records. And in this data, since we know that there is only one record prior to the baseline record, what I have used is that I have used the if first dot baseline or first dot param CD condition, that is for each subject, because we have already sorted by uSubject ID and param CD, when we apply this, that it will check for each subject And when it is the first record for each param CD for that subject, we are keeping the base eval variable as missing. The next step is we are identifying the base value. So as we said that the baseline flag it will be populated as Y for the baseline record. So in this case, where the ABLFL is Y, the AVAL value of that record will be considered as the base value. So we are storing the AVAL or the base value in our base eval variable here. Till now, what we have done is that in this statement, we have kept the base eval as missing for the pre-baseline records, and the we have identified the base value for each subject param CD combination using this statement. Now the thing is that we want to populate the base value for each and every baseline and post baseline records. So to do that, what we are doing is we are using this statement that if base eval is not missing, we populate the base as same as what we have identified as the base value. Why this will work is because in the PDV of SAS, till this, when we have identified the eval value to the base eval, in the background or in the PDV of SAS, this base value will be populated for each and every record, the value of eval. To make it as a base value, we are using this condition. So if you want to run this, you will see that till this point, we have derived the base value. So if you see that we have the base eval populated for the baseline as well as the post baseline record, but we are keeping it missing for the pre-baseline records. And from the last statement which we have run, we are making sure that the base eval values is copied to your base value when the base eval is not missing. So till this point, what we have done is we have created the base value for the dataset. So now next is the derivation of your change and the percentage change variable. So the change variable is nothing but the difference between the eval and base value. So since we are applying some mathematical operation here and we want to make sure that none of these two variables which we are using in the mathematical operation are missing, because if these are missing, the resultant value for change will be a missing value. So to ensure that type of mistake is not there, we are already putting a filter or a condition that if the base value is not missing as well as the eval is not missing. And another condition which we have put is that when the ABLFL is not equals to Y. Why? Because again, the change value will be only populated for the post baseline record values. It will not be populated for the baseline or the pre-baseline values here. So by applying this filter of ABLFL not equals to Y, we are already removing the records which are identified as the baseline records. And when we are applying this condition, that is the not missing base, we are making sure that the pre-baseline records are also not being considered in this operation. So by applying these three conditions, we are making sure that we are not using any pre-baseline or the baseline records for the change variable to be populated. Along with that, we are also making sure that the mathematical operation should be performed only when both the eval as well as the base values are not missing. So in this way, you can derive the change variable. The next is the derivation of percentage change. So the percentage change, for percentage change, we will use the change value as the numerator and the base value as the denominator. And we will, since it's a percentage, we have to multiply it by 100. This is the formula which we use for the percentage change. And since we are using the base value in your denominator, we have to make sure that we are not considering any base value which is where the base value is equals to 0, because then the mathematical operation will be invalid or it will result in infinity result, which we do not want. So we have we are putting a filter that the base value, when the base value is not equals to 0, calculate the percentage change by applying this mathematical operation, that is the division of change and base multiplied by 100. So let's run this complete data set and see the resultant data. So you can see now that we have the change value, also change variable also being created, and since there are only one post baseline record for each subject, we are having only one record being populated for the change, and respectively the percentage change value is also populated. So right now, since we did not apply any rounding off, or we have not restricted to any decimal precision value for percentage change, we are having the complete value coming. So if you want to, if you're in your study, there is a requirement that you have to limit the percentage value to any particular decimal precision, then you can use the put function accordingly or the round off function accordingly. So in this way, you can derive the baseline flag, base change, and the percentage change variable in any of your ADaM BDS structure. Let me know in comments if you have any doubts or concerns regarding this video, or if you want me to cover any specific topic in my next video. Till then, thanks for watching.